Okay, our next speakers, Allison Carlson, Dr. Carlson the son. I just think of her as a Eucoma's queen. She is a flower lover and researcher at North Carolina State University. Also has done so much for the AFCFG and has shared her knowledge frequently. So thank you. And also participating in this program with her is John Dole. He's another doctor. We just call him John around here. Researcher, author, flower guru extraordinaire. He's professor and department head at North Carolina State University Horticulture Department. Both Allison and John have done extensive studies on post-harvest as well as other things. And so they are here to answer all your burning post-harvest questions. So, Allison, you have the floor.
Excellent. Okay, all right, good morning. So John and I are here today to answer all of your burning post-harvest questions. We've already had a few this morning, so we'll cover those for you as well. John and I are going to tag team this talk, so I'm going to start it off first, and then he'll take over. And yes, my name is pronounced Allison, even though it's spelled with a C. It's a soft C. Long story. I can tell you about it later if you want to hear. Or I'll just give you my mom's cell phone number and you can ask her. All right, so here is an overview of what John and I are going to talk about. We have several different topics we're going to go over. Hopefully that'll spark some questions for you guys if you don't already have some. And we'll try to take questions at the end unless it's something that it's really burning and you need to know it right now. So we're going to go over some general post-harvest handling procedures. Since there are a lot of first-timers in the room, we'll go over that, so that'll be some good information. We're going to go over some research that we've done at NC State on the harvest time of day and what time of day is good to harvest your flowers. The results might surprise some of you. We're going to go over some research dealing with water quality, and then the effects and control of ethylene. So we've already had some questions today about ethylene, so we'll talk about that some more. And then some species evaluations that we've done at NC State: Celosia, Aromaris, Marigold, and Snapdragon. All right, so first, general post-harvest handling. So in order to for maximizing your post-harvest life, there are many factors that can affect vase life of cut flowers. Okay, vase life is very, very important, especially to your consumers and for your reputation, so it's important to maximize it. So there are pre-harvest factors, harvest, so when you're actually cutting the flower, and then we're going to go over some general factors, and then post-harvest. All right, so first of all, and I know you guys know this, but quality is one of the biggest factors. If it's a poor quality flower, it's going to decline faster. So the zinnia on the left is obviously not good. Don't cut it, or cut it and toss it. Don't even bother trying to sell it because it's going to decline faster. You want to make sure you're harvesting high quality flowers. And then there are cultivar differences. So this is why John and I always have research to do, because there are cultivar differences. So this is an awesome chart that John put together of all the different cultivars, well, not all of them, but a large group of sunflower cultivars. And you can see the differences overall in their vase life. Vase life is the y-axis, the one that goes up and down. And then there's two different treatments. So the blue bar is with just water as the solution that they're being held in, and then the red bar is them using a holding solution. So like a Chrysol number 2, that's a holding solution, the solution with the sugar in it. So not only can you see the differences between those two holding solutions, the water and the preservative, but just how the bars go up and down depending on the cultivar. So it's important for you to understand that there are cultivar differences as well. All right, the developmental stage. So the time that you harvest the flowers are really important. And every flower, in general, has a different time to harvest it where you can get the maximum vase life out of it. So this time that you harvest is going to vary with the market. So whether it's direct to the consumer, you may want to harvest them a little later when the flowers are a little more open, because that's more visually appealing, because it's going directly to the consumer. But maybe to a retailer or a wholesaler, you're going to cut things a little bit tighter because they might be held for some time. It'll take some time for things to sell, and it'll make sure you get the maximum vase life, especially for the end consumer that buys them. And this photograph shows the optimum time to cut a sunflower, like just when those petals are starting to lift from the disc. That's when you're going to get the maximum vase life. You may want to cut them a little bit later, like I said, if they're going direct to the consumer, just because they love the color and it draws them to your booth and things like that. So here's a good picture of this is peony. So for peonies, you especially want to cut them when they're tight. It's called the marshmallow stage. So if you actually squeeze the bud, it'll kind of have the consistency of a marshmallow, and that's the optimum time to cut that, and you'll get excellent vase life, and you can store them in the cooler as well. But obviously, I'm sure you guys sort of have an eye for this now. Cutting them at that later, fully open stage, you're going to get a couple days vase life out of that before the petals start to fall off, and it's just going to fall apart. All right, so carbohydrates are really important for cut flower post-harvest. So they are the sugars that fuel the plants. All right, so the flowers, when they're on the plant, they're getting the carbohydrates through photosynthesis. The leaves are gathering the light and creating sugars through the photosynthesis that are feeding the flowers. You want to make sure that the carbohydrates are at the highest possible levels in your flowers when you cut them, because it's fueling the flowers. It's like the energy that they need to keep alive in the vase. It has effects on how the buds open. So giving them sugars and carbohydrates will make the buds open better. They'll open, they'll actually open on some things. And they'll help them to develop and maintain color. So like with things with Lisianthus, when the buds that aren't open when you cut them, as they open post-harvest, if they're given more carbohydrates and even decent light levels, the color of those ones that are opening post-harvest will be better. And same thing with snapdragons as well. So the sources for the carbohydrates, like I mentioned earlier, when the flower is on the plant, they're made by the leaves and then stored in the stem. But obviously when you cut it from the plant, it's not getting that source from the mother plant. So therefore you need to supply it through a post-harvest solution, like the Floralife fresh flower food that's pictured over there. And Chrysol, we're also equally representing them too. So Floralife and Chrysol. All right, and then temperature is also another important post-harvest factor. So in general, there's always those plants that don't fall within the generalities of most things. Like that's just life, there's always an exception. But the warmer the temperature, the faster the respiration rate. So respiration is how fast those plants are using those carbohydrates. So it's like their metabolism for a human, like how fast you're burning calories. So the warmer the temperature, the faster the plant is using those carbohydrates, which is why it's good for you to put your product in a cooler if the species can tolerate your cooler temperatures. The warmer the temperature, the faster bacteria grow. So the bacteria that get introduced into your bucket water from the stems, or if maybe your buckets aren't as clean as they should be, those warmer temperatures help bacteria grow. And the bacteria in the water is not necessarily a good thing because it plugs up the stems. So we want to make sure those bacteria do not grow fast. And then the higher the temperatures, the more stems can bend in storage. You can especially see this with gerberas in the photo here. They were stored warm, and then when they came out, the stems started to bend post-harvest. All right, so temperature drives respiration. So respiration, again, how fast the plants are using that energy in the carbohydrates. So for every 10 degrees increase in temperature, the respiration rate doubles. And that equates to a 1-day vase life lost. So that's, that's significant. That can be significant for your flowers. You want to make sure you get the field heat out of the flowers as soon as possible. Some flowers like to be cooled slower than others, like lilies. You can't take them direct from the heat and put them right to the cooler because it's too much of a shock for them. But you want to make sure you make that transition and get that field heat out as soon as you can. You want your cooler to be between 34 and 38, close to 32. So as close to freezing as you can is optimum for most species, but it can get kind of sketchy with some coolers. The closer you set them to freezing, there may be a glitch and some things might actually freeze, which is not good. So, make sure you know your cooler, but these are just recommendations of where your temperatures should be about. You want them to be as cold as possible. So 34 to 35 or 34 to 38 usually ends up being more practical, and especially for energy costs as well. So there are a few crops in particular that are cold sensitive. Like I mentioned, the oriental lilies, some zinnias can be cold sensitive. We've found ours that are stored long term, like 4 or 5 days, they tend to get more sensitive the longer you store them. Celosia, and then some tropical species. So these, you'll want to gradually cool them and make a transition from like the field to maybe your barn into, and then into your cooler, just to slow that process down. So the take-home message for storage is to have it be as short a duration as possible and as cold as possible. I mean, for you guys selling you cut it the day before and you sell it the next day, or you cut it that day and sell it that day. You may not have to store as long as some other venues. All right, so botrytis. Botrytis is one of the main diseases of cut flowers and foliage. It's often present during production and then shows itself during post-harvest and becomes especially an issue. And especially if you're storing and shipping, the buildup in the cooler temperatures and also the higher humidity that happens in a storage and shipping situation, botrytis loves that. They love it cool, and they love lots of water and condensation that can happen if the temperatures are fluctuating during your storage times, or if you're harvesting flowers that were just rained on or irrigated. That free water, botrytis loves that. So you want to make sure you're careful of that. You want to try to control it during production. If you're seeing that you're having problems post-harvest, not necessarily during production, but you're seeing that once you cut the flowers and store them, you get botrytis issues, you may want to look at your production practices and try to control it there first. And those are, geranium is on the left, to the botrytis growing on it, and then the strawberries, I always see that in the grocery store. It makes me really sad when I see that on the strawberries that I paid lots of money for. And then in rose, which is one of the common cut flower crops that it's on. So here's a photo series taken where it'll help you guys see what the early signs of botrytis are and then how it develops, because obviously once it gets to that last rose photo or any of those previous photos, it's way too late. So it starts off as these little specks on the petals. Looks, not so bad. But then it starts to get bigger, and you get larger necrotic areas and some bluing of the tissue, especially on red petals. Then it gets bigger and bigger, and then you start to see the fuzzy part start to form, and then all hope is lost. That flower is just dead. And that's not what your customers want to see. You know, you may not see it, but as they take it home and the disease progresses, that's not something that they want to look at home.
How many days did it take to do that?
That series was about 3 to 4 days, so it progresses fairly quickly.
Yeah, so John said that was about a 3 to 4 day progression of that disease. And yeah, it happens pretty quickly. So reducing botrytis problems. So here's how you can do that. You want to prevent condensation on the flowers so that the free water that can form on the flowers, the botrytis is a fungus and it loves that. So you want to try to prevent condensation. You want to keep your cooler and production floors dry. So make sure you're doing proper cooler maintenance and making sure you don't have water on the floor and that there's not plant material lying around on your cooler floors. You want to try to give some breathing room in your buckets. I know it's super easy to just try to cut and stuff as much as you can into each of your buckets because space is money and time is money, but you want to make sure that you're not smushing them too much because the airflow between and around the flowers is going to prevent botrytis from developing. And that's even true in your production situation as well. You want to avoid mechanical damage, so here's another reason not to smush way too many flowers into a bucket. You want to make sure you're not damaging the stems and the petals and the leaves because when you damage the plant material, that allows a place of entry for the botrytis spores to get into and really infect your plant material. You want to make sure you're working clean. Being sanitary, making sure that all of your surfaces are getting wiped down, your clippers, that your production areas are, weed-free, you don't have a lot of leaves and petals and dead plants lying around. You want to make sure you're working clean. And keep your flowers dry. So if you just had a rain, cutting all of the flowers, maybe before you put them in the cooler, leave them out in your barn or whatever area that you might have to let them dry off a little bit before you put them into that cooler that tends to have a higher humidity that can facilitate botrytis growth. So just be aware of that. And then keep your floors dry. So just work dry. All right, so a little bit more about cut flower handling and a little bit more about bacteria. So the decline in vase life, a lot of it is due to a lack of water uptake. So water uptake and that fun word, turgidity. You want to make sure that your flowers stay hydrated all the time. And this decline in water uptake, there's about 3 different factors that can cause the decline in water uptake. So the stems can be blocked by microorganisms. So this can be bacteria, fungi that are naturally on the plants and in the tap water, or it can be built up in buckets or vase solutions. So your floral preservatives, cleaning your buckets properly, are going to help prevent some of the microorganism buildup. You want to make sure that you're absolutely stripping any leaves that are going to be in your vase solution or in your bucket solution. And make sure that you're telling your customers to do that as well. I think that's one of the main things that consumers do wrong when they're handling their flowers at home is they don't strip those leaves. So make sure you're communicating these types of post-harvest things to your customers as well to help them be successful with your flowers. So you want to make sure you're reducing that bacteria and microorganism buildup. You want nice, clean water so that your stems can take it up. I like to use this metaphor for this. The stems are like a straw, and it's easier for you to take up water through a straw when it's like plain water. It's nice and easy to suck up. It's the same thing for the stems. When it's nice, good water, it's easier for them to take it up. But if you put that straw into a milkshake, it's really hard to drink a milkshake through a straw. But if you're putting your flowers into water where there's lots of bacteria and gunk and leaves and just a bunch of crap in there, it's hard for your flowers to take that up. So it's really important to have clean water. All right, so the decline in water uptake can also happen from air plugs in the stem. So air bubbles can actually form in the stem. There's some debate on how they actually form. Scientists are still trying to figure out exactly what the mechanism is for that. But it can be taken up when the stem is cut and in air, and bubbles can get in there. But post-harvest solutions help remediate that. And once you actually put it into the solution, you want to make sure your water's nice and deep, because that can help push that bubble out of the bottom, the deeper the water is, and get rid of that. So you don't have to cut underwater in order to prevent that. So you want to recut, and then you can cut underwater if you want to, but when you do that, you also want to make sure that the water you're cutting into is clean, because you don't want their first drink of water to be dirty water. And then there's these pesky physiological blockages that just, it's going to happen. The flowers are going to die. That's what they're meant to do. So they're just going to do it eventually, and we all have to come to terms with that. So there's generally no way to overcome it. It's just senescence. The plant's doing it. Their cells are breaking down. It's getting into the xylem that's taking up water, and they just, it's their time. All right, so sanitation best practices. So you want to make sure you're clean. Using a cleaner with a residual effect is good. So for your buckets and your tools, anything that you're putting your flowers in, you want to make sure is very clean. So at State, we use the Chrysol Professional Cleaner because it has a residual effect that helps keep things clean. You want to make sure you're regularly sanitizing your tables and your cutters, like those big bulk choppers. You know, they're coming into contact with the ends of your stem. So you want to make sure that you clean them fairly regularly. I know that's not like the highest thing on people's priorities when they're out there, when everything's blooming and you're just trying to get it out. But it's really important to put that on some sort of schedule to sanitize it. And then also your coolers. Keep your coolers clean. Keep your trash cans emptied, daily or as much as possible. This helps to prevent botrytis and control ethylene. So we have a whole other subject on ethylene, but it's the senescence hormone. So you want to make sure you clean that out as often as possible. And then of course, just general good horticultural practice, keep your hose nozzles off the floor. So you limit that transfer of bacteria and fungi. All right, these are some lovely photos that, wasn't it Gay from Chrysol shared? Are these your photos, John?
I think a couple of them are gay.
Okay, so I'm glad that I didn't firsthand experience this because I think I would have had a minor heart attack. So this is what not to do. So the first picture is of a stem stripper. So you want to make sure that that's always cleaned out. The debris around things should be cleaned up and inside, and the sinks, kept clear, buckets clean. You clean out your drains, the insides of those buckets. Now, if you wouldn't drink out of your buckets and vases, I'm serious, if you wouldn't drink out of them, you should not put your flowers in them. So if you're not prepared to drink out of your buckets, then you need to have an afternoon of cleaning, all right?
Who here would drink out of your buckets today?
Raise your hand if you would drink out of your buckets.
All right, very good.
Yeah, okay, excellent. All right. Okay, all right, okay. High polluting flowers. So there are some flowers that just happen, we call them dirty flowers. They're dirty. They're always going to cause the bucket water to get nastier faster. So this is, something that you seasoned growers have learned, and that you ones that are starting will learn very quickly. Yarrow, sunflowers, mums, gerberas, celosia, dahlia, and zinnia tend to be pretty dirty. And a lot of those, the reason behind why they're so dirty is because they have hairs along their stems. So those hairs collect dirt and bacteria, and also offers a really fun place for bacteria to grow while they're in the bucket. So you want to watch out for that. A lot of growers use Chrysol, the CVB product, the chlorine product, for species that are particularly dirty. Yeah?
Are we going to get access to these slides?
Yes, I'll turn them over to Judy, so that way you guys can access these. Yes, absolutely. All right, and then we could do a whole talk on just the differences between all the different floral preservatives, because there are a lot of options for you guys out there, and a lot of times it's just best for you to try different ones to see what works for your practices and your flowers and your farm. But here's just some general floral preservative mixes. But for floral preservatives, there's the ABCs of floral preservatives, so especially a holding solution. It has an acidifier, which lowers the pH to about 3.5 to 4. A biocide that helps to kill those bacteria that are pesky, and a carbohydrate source, so giving the flowers energy. So it has the A, the B, and the C. So there's hydrating solutions. The hydrating solutions are meant more for just encouraging water uptake. So they're usually used for a short time, up to about 4 hours, and just help to encourage water uptake. They do not have a carbohydrate in them. So they have the acidifier and the biocide. And then there's holding solutions. So Rita was mentioning the Chrysol number 2. That is a holding solution. Chrysol number 1 is a hydrating solution. So they number them for you, so it makes it easy. A holding solution can be used after a hydrating solution if the species needs it. And the holding solution has all three, the acidifier, the biocide, and the carbohydrate source. And that can be held for up to 2 days or for as long as you need the flowers in the buckets. And then there's a vase solution. So the vase solution has a higher carbohydrate percentage, so it has more sugars in it, and that's what's in the little packets that some of you might give to your customers. So that's what gets used through to the final vase life of the flowers. There are also species-specific floral preservatives, so ones especially that are for bulb crops. So they have hormones in them that are specifically formulated for bulb crops. So for lilies, the lily-specific preservatives are especially effective. So they'll come in powders and liquids and pills, big buckets and jugs and packets and tea bags. So there's a lot of options that the floral preservative companies have come up for you guys to be successful with floral preservatives, if that's something that you want to use on your farm. So be sure to speak with your representatives from Floralife or Chrysol, and they will have good recommendations for you if you're having like really specific problems. They can be extremely helpful. All right, so in summary, work clean and dry. Store and transport as cold as possible, and then use the proper treatments, the proper preservatives. All right, so that's all I have for the general post-harvest, and we've got one question. Go for it.
Have you all ever cleaned buckets with the simple breed that
We haven't used it, but when I worked, at State we used the Chrysol cleaner, but before that we also used just like antibacterial soap and cleaned it out. When I worked on a flower farm, we used bleach and dish soap, and that was perfectly fine. I don't see why there'd be a problem using the product you mentioned, but we don't have direct experience with it.
What's the humidity in the cooler supposed to be? What kind of that level? A general?
Above 85%, closer to 90, and below 100. No, the question is, what should the humidity percentage be in the cooler? So above 85, it would be better to be 90 to 95. It depends on how long the flowers are going to be in there. If the flowers are in there for just a short amount of time, then the humidity is not as big a deal. If they're going to be in there for a while, then the cooling process tends to dry humidity out, in which case then, as long as the foliage is dry, like Allison mentioned, you can put water on the floor, to raise the humidity inside the cooler. So if you're going to store stuff for a while, the humidity should be higher.
95, you said?
Yep, 90 to 95. If you get too close, most of the time this is not something we have a whole lot of control over unless you've got one of those the newer coolers with very precise humidity control. So many times we're just reacting, but if it gets too high, then as the cooler cycles on and off, you get condensation.
So I have two questions. Cleaning buckets, have you guys experimented at all with vinegars? Have you ever washed the buckets? And is there organic preservative?
Yeah. There's lots of, we're looking at each other because this is part of what Allison's been working on for a postdoc, was an organic preservative. Floralife, Chrysal, the companies are all working on it. There is no certified effective floral preservative that's for organic, not yet. The problem is the biocide. You can get all the other components certified organic, but not the biocide. We're all working on it, trying to figure that out. Yeah, okay.
Well, nobody talked about quick dip, the best way, the most effective way to use it, once enough, or do you need to do it every time you cut?
We've actually only used it a little bit. So we don't use quick dip all that much. We tend to use the other hydrating solutions. So that's part of a problem with doing the work. To test all the products and to test them all correctly, you get these really huge experiments. And so most of the time we just don't have enough flowers to be able to test them. So we tend to stick with a hydrator from Floralife, a hydrator from Chrysal, a holding from Floralife, a holding from Chrysal, that sort of thing. So we've not tested all the products.
You said a really deep bucket. So how deep of water are you talking about?
Well, we'll use a 5-gallon bucket as an example. Just not necessarily half, but maybe like a third full.
Okay.
So, you don't want just like, I know sometimes it's easier to transport and carry buckets that just have a little bit of water in the bottom, but you want to make sure that you have a good, 4 or 5 inches deep of water. Yeah.
Will you say something about singeing the stems and the poppies, or maybe knowledge?
I'll get there. Yeah. For the most part, we have not found that that's effective. Sorry, I keep forgetting. I'm always bad at that. Every conference I'm supposed to do that and I forget. So yeah, keep yelling at me. Everybody else is. We have tried on a couple, we tried poppies, we've tried poinsettias, singeing. See how bad I am? See how bad I am? Singeing, the question is, singeing. Can I talk about singeing?
Singeing the stem ends, does it work or not?
I'm hard to train. We tried, no, doesn't work. There is some literature for, I think it still is for poppy, saying that it does. There's one paper, but when we tried it, we could not get it to work. So just nice clean cuts on those flowers. Anything with sap. I think there was a question last night about euphorbia snow on the mountain. So anything with, you got to watch the sap. Anything with sap, you just cut it, put it in the bucket, let the sap dilute out naturally. Sap doesn't have to be a big deal. And then you take it from that bucket and put it in another bucket and it will hold fine. So yeah.
How long should it take to dilute out?
How long, thank you, Allison. How long to let it dilute out? A few minutes. A lot of times by the time you get the bucket filled, you go on to your next bucket, so forth, and then you can take them, you take your first batch out. You know, a lot of times you will give it plenty of time just by that it takes a while to get all the flowers in and all the flowers out, and then you're done. Yes, in the back.
Are there any flowers that prefer just clean water, no holding solution?
Yes. Okay, so the question was, are there any flowers that prefer just plain water and no holding solution? There are. One most notably that I've been working with is eucomis. It loves just plain water. The vase life actually declines if you use a floral preservative with them. But in general, I'd say that most flowers are either benefit from a holding solution or are unaffected. So there aren't a lot of species where it actually reduces the vase life to use them. And we're working on a cut flower post-harvest book that has all these recommendations in it for what to use with what. So yeah, you can look forward to that.
One chart we took out was, we've done, and Allison's been a big part of this, part of the ACFG cut flower trials, we do anything that looks particularly good, we'll put into a real basic post-harvest test. That's with and without hydrator for 4 hours, followed by with and without a holding solution for 44 hours. So, you know, it's a total of 2 days. And the net results is holding solutions work. Okay, they really do. Hydrating, it's less clear. The commercial hydrating solutions work for a few species. So the default there is probably a good clean water, and then put it into a holding solution. But most species, a floral preservative needs to be used in there somewhere for most. And like Allison said, if it doesn't really help, significantly help, at least it doesn't hurt. So you want to keep things simple and we probably should.
Yeah, you can talk to us afterwards if you have more questions about that, and if we have time at the end, but we're gonna move on now.
All right. So as Allison said, we've got some specific studies that we're going to cover, and a couple of these studies were done by Iftikhar Ahmed, who was a visiting professor from Pakistan. He was with us for 3 years, got a lot done, and then Allison, after she graduated, took his position. So the first one here is looking at time of day, and you know, you've probably seen the literature. There's kind of a standard story, and I have to admit, I wrote part of that story, and so now I'm changing that story. So you can go back to some of the things I wrote, and just scritch. Morning harvest, the benefits there: you avoid the heat, you have higher water content. We heard last night about flowers that don't hydrate well, or that tend to wilt quickly. You harvest them early, and it was interesting. Early means really early. Okay, and there was some good discussion on that last night, so that's a classic case there. And then, of course, the nice thing about harvesting early in the morning is you got the rest of the day to take care of the processing and to get it all handled. Afternoon harvest, we've known that increases the carbohydrate content of other plants. Okay, we do have a lower water content because by the middle of the day, the heat is up. The plants are transpiring, they're pulling up water, but nevertheless, they're losing as much water as they're pulling up, and the overall water content tends to go down. And there's also some literature out there, in particular with unrooted cuttings. When you're growing bedding plants, the small shoot tip cuttings come in from suppliers, and we know from work in that regard that that afternoon harvest reduces ethylene sensitivity. Okay, so we were curious about how this would affect cut flowers. There have been a few studies with cut flowers, but it's mostly been the big ones, roses, alstomary, and carnations. So we were curious about how this would affect the situation in the field, because those cut flowers are mainly greenhouse grown, in the big flower growing areas. So we harvested 3 times a day. The morning was 7 to 8 a.m., the noon was 12 to 1, and then afternoon was 5 to 6. Then we checked for post-harvest performance. Either they went directly into the flower cottage, which is our post-harvest room, or they went into 2 weeks of storage. Again, the idea here was that if time of day affects carbohydrate level, and flowers lose carbohydrates as they are stored, then what effect will time of day have on storage? Okay, so bring that all together. And then we looked at three major ones here: Lisianthus, ABC purple, marigold, deep or double eagle gold coin, and then of course Zinnia, deep red, Benares giant, which is a real classic cultivar that we use for a lot of our stuff. So, okay, graphs. All right. So what we have here is, of course, the cursor's not showing up too well; it's too small. But on the lower axis, we've got no storage, 2 week storage, and then morning, afternoon, or morning, midday, and afternoon harvest. And then we've got vase life here. The blue is Lisianthus. The gold is marigold. The green is zinnia. And we can see in general that, let's look at the no storage ones here, vase life went up as afternoon harvest went up. Okay? And then if you look over here with the storage, you can see, first of all, things didn't like to be stored for 2 weeks. 2 weeks is kind of a lot, so we were pushing it. But we really wanted to see, what it would be in a maximum situation. The zinnias, of course, hated storage, and we're going to see this when we talk about zinnias this afternoon. We'll see some other results we had. But you can see really clearly here with the Lisianthus, the marigold, and the zinnias, even more so when they were stored, afternoon harvest helped them to last longer. Okay, so we're not trying to complicate matters for you, but keep in mind that this is something that you may want to keep in mind. If you know you really need to store something, you've got a wedding in 2 weeks, you're near the end of that flush, and you're not sure the second flush is going to come in time, or the third flush or whatever, harvest them in the afternoon and do everything you can just right to make sure that they will last long enough to be there for that wedding. Yeah.
What time of year were you doing these?
This was summer. Iftikhar did multiple reps, so it was several times during the summer. It wasn't just one time. He repeated everything twice. So yeah, this is summer harvest. All field-grown stuff. Okay, so definitely afternoon was better than morning or noon for vase life extension. Now this is 3 species. Keep in mind we don't want to, there's other factors such as the hydration issue. Storage reduced vase life, but even then the Lisianthus and marigold that were harvested in the afternoon, there was less of a reduction. So they did a little better in storage when they were afternoon harvested. The part we're not showing you here, because you really would glaze over if we showed you all this stuff, is all of the carbohydrate analysis. So where Iftikhar took all the sugars, or took all the parts of the stem, flowers, leaves, etc., and then looked to see which carbohydrates were in what quantities in each of those parts. And so able to link it back to the time of day. And so for Lisianthus and marigolds, there was a clean pattern, not for zinnias, but zinnias we also did see as clean of a pattern in terms of the afternoon harvest. So very nice. So lisies and marigold definitely should be harvested in the afternoon for the longest life. And it's enough to add some time that you would notice, not just what we would notice statistically. Okay, turn it back over to Allison.
All right, I'm back up here for a couple of slides. So one of my research projects for my master's, and Iftikhar did some of this too, was looking at water quality. So the water that you're putting in your buckets and in your vases, how that affects vase life. So what we looked at in particular were the pH. So we did 3 different pHs. We did an acidic, a neutral, and a basic pH. And then we also looked at the electrical conductivity. So we added sodium chloride, so table salt, to the solutions to gradually increase the electrical conductivity of the vase solution. So, in general, I've said this, high quality water promotes water uptake. Water uptake is key. The EC level that you want to have of your water varies with the species. In general, it's good to have a little bit of EC, which is what your tap water has anyway. And if you add a floral preservative, it's going to add a little bit of EC to the water too. It has to do with water balance in the stem and how water moves from the bucket and into the stem. So initially, your pH is going to be about 5 to 7, depending on your water source. And you want to amend that to a target range of 3 to 4. Okay? So an acidic pH. So what we found was for the pH that in general a low pH was optimum for almost all species. And if it wasn't optimum, it just didn't have an effect. There were none of the species that we tried. We did, let's see, I did 4, and then Iftikhar I think did 3 more species. We did mums, zinnias, hydrangea,
roses.
carnation, roses. I even did eucomis, of course, everything with eucomis.
You can do snaps.
And snaps and callas. Did we say that?
Yeah.
So we did this with several different species, and an acidic pH was good for all of them. So tap water, the pH is usually too high, so you just want to adjust it. There are different ways that you can adjust the pH. You can use a floral preservative, or commonly citric acid can be used to lower the pH as well. So in the graph that's up here, it just shows very simply that as the vase solution pH increased from 3 to 7.6, the vase life went down. So the acidic pH was the highest. And then looking at the electrical conductivity, so this was adding the salts to the solution. So on this graph, you can see on the lower axis, the EC is increasing, so the water is getting more salty, which we know is not necessarily a good thing. And then the vase life is on the other axis. So we did this with the same ECs, but we did it with a holding solution, so with a Floralife Professional or Chrysol number 2, the one with the carbohydrate in it, and then we did it without a holding solution. So in general, you can see those lines, the vase life trends down as the EC increases. But the interesting thing to note is that the slope of that line, so how fast that line decreases, is a lot less when you use a holding solution than when you do not use one. So that translates for you guys, if you have poor water quality, if your water quality is really high, if there are salts in your water, using a floral preservative will help to reduce some of those negative effects that poor water quality can have on your flowers. I know there are particular preservatives that are formulated for like water with high alkalinity that helps improve vase life if you do have hard water. So those are some things that you want to keep in mind as well. So you want to know the baseline of what your water source, how high quality that water is. All right? And that's all of that.
All right, we're going to switch again. Ethylene, ethylene, ethylene. Okay, we had a couple questions on that already. And Rita talked about the silver products this morning, so we'll get into ethylene. It's a natural ripening hormone. It's produced internally by flowers as part of the natural process, okay? And then it's produced externally by a number of different sources. Fruits, Rita mentioned that this morning, and vegetables, not storing your flowers in with fruits and vegetables. Mechanical damage triggers ethylene production, okay? And it's not a huge amount, but just the jostling of the flowers in the bucket, you're going to get a small amount of it being produced. Exhaust from combustion engines, but having said that, most of that testing is on much older vehicles, and I would say newer vehicles probably don't have nearly as much as they used to. Cigarette smoke, barbecues, fireplaces, space heaters, any sort of combustion, okay, will produce a little bit of ethylene And then bacteria, yeast, and fungi, botrytis produces ethylene. So infection of flowers with botrytis will make botrytis even worse because of the production of ethylene. And then, of course, air pollution. So mainly it's going to be more the first ones at the top there. Okay, so what are the signs of ethylene exposure? The most common is leaf, flower, and bud abscission. The photo right here, which happens to be a wax flower, but we've got similarly wonderful photos of delphinium and larkspur where all the petals have fallen off. So classic symptom is petal shattering or petal loss due to ethylene. Bud abortion, we tend to see that more during production. Rapid flower senescence, this is the tough one, because how do you know that a flower died due to ethylene, or just because it was too warm, or because it was too much bacteria, like Allison talked about? So this one can be a bit of a lurker. You could have ethylene issues. Ethylene could be the problem, but it won't, unless it does that nice clean symptom of dropping its petals, then you may not know that ethylene actually is the issue. The last one there is fairly classic, and that's epinasty, and it's the twisting and turning of the foliage. Tomatoes are a classic for that. We do ethylene testing in our lab. We get samples periodically from folks who are wondering about problems in their greenhouse, such as a cracked heat exchanger. And one thing you can do, if you are a little bit worried about ethylene, if you're seeing some of the symptoms, is put tomato seedlings in the greenhouse. Tomatoes are very sensitive to ethylene. They get this wonderful epinasty, the twisting and the turning, which kind of looks like herbicide damage. And so that'd be a good way to check and see if you've got any ethylene issues. Well, large-scale ethylene issues. Okay, so minimizing low temperature. Allison talked about low temperature earlier. Low temperature reduces the production of ethylene, and it reduces the sensitivity of ethylene. When you get down below 40 and closer to the temperatures that she mentioned, then ethylene sensitivity goes way down, and you got a lot more flexibility there. Anti-ethylene agents, we'll talk about that in a minute. Rita mentioned one already this morning. Remove the sources, clean up the greenhouse. Allison mentioned several times keeping the place clean. Rotting plant materials are a really nice source of ethylene. So, clean that up. Okay. The anti-ethylene agents, at this point there are two that are registered for use in the United States. And as Rita mentioned this morning, STS, or ABB, is registered only in certain states. Okay? It's for the first solution, it's the first drink right after harvest. When the flowers, they take up a bunch. If you hydrate flowers and then put it into the solution, it may not take up enough, okay, because the first drink has saturated the flowers. So the first drink right after harvest, you use it only once. You can overdose this. You can get too much, you can get damage from multiple applications of the STS or ABB. It protects for the entire flower life, and that's really nice. Once it is sucked up into the stem, it goes all the way through the stem and into the flower, and it is protected. I think I've got the states registered there, but I think there's several more states actually now. Now that I look at the list and realize I think it's supposed to be a couple more on that list. Silver, it's a heavy metal, and disposal is an issue. Follow the directions that come with the product. And if we had more time, I'd show you some of the fun ways that growers have figured out how to use just exactly the right amount of STS. Allison, talked earlier about making sure you got a lot of solution in the bucket. What some growers have done is they put just the minimum in with the idea that the flowers suck it all up, and then they don't have anything to dispose of. So the growers that do use STS have done a really nice job of figuring out how to use it so that there's nothing left over that they have to dispose of, because that just makes life easier. Okay, because you can't just throw this stuff down the drain. It's got silver in it, okay? So please be careful of that. Now, ethyl block is MCP. Okay, this was developed actually at NC State. It's a non-toxic gas. It's used on fruits and vegetables. So it's not just for the flowers, but it's used on edible crops as well. It's also available as sachets, these little things that you can put in boxes, and when they get moist or when the humidity's up, then the gas tends to it tends to off-gas. In other words, it produces the gas. Okay, protection lasts up to 10 days. Okay, no disposable problem. This is, you can come right in right after the fact. It's a very, it's not certified organic, but it's very low toxicity. In fact, they really haven't been able to find any, human problems with it that I'm aware of. The problem with it is just not as long lasting. It's a gas, so it penetrates the tissue very easily, much like ethylene penetrates the tissue very easily, but then it also tends to move out of the tissue. So within the plant, there are receptors for ethylene. Okay? Ethyl block and STS blocks those receptors. The problem is the plants are producing new ones. STS stays in the tissue and blocks the new receptors. MCP doesn't. And so that's the difference. The fact is, it's a lot softer and easier to use, so, and it's more widely registered, so many of you are probably going to want to use that. Okay, here are some Asiatic lilies. What sort of species do best with this? Rita mentioned a couple this morning, and then I'll add Asiatic lilies to it. The snapdragons, I think Rita mentioned, Larkspur delphinium. Okay, so there's several major species. And there's a number of Trachelium, lupins, there's a few others that aren't as... Sorry? Sweet pea, oh yeah, sweet pea is like the poster child for it. Yeah, sweet pea is very, yeah. It's hard to get really good base life on sweet pea without some sort of anti-ethylene. Thank you. Okay, so this is Asiatic lily in water. Lovely, don't you think? This is the new minimalism. Okay. Don't need petals anymore. All right, and notice the buds there have not opened up. Okay. Or as a friend of mine says, the botanical look for anything with not big petals. Okay, here's STS. All the, the petals are still on, and the buds have pretty much opened. We've lost a few there, but this was, I forget which day it was that we took the photos. In MCP, certainly much better than the water, but not as much as STS. Okay, everything in life there's a trade-off, and so you've got to weigh which product you want to use. Okay, all right, looks like we're on time. Okay, the last part here is new species. We do the trials, the ASCFG trials, and anything that does really well in the trials, we will take and harvest and do what we call the stage 1, which is real simple, what I mentioned earlier, with and without hydrator and with and without a holding. And then the ones that look really good in that situation, we take them further and we basically do a whole series of tests. And Allison's done this with Eucomis, just trying to give you all the post-harvest information you would need to figure out how to handle them. And so we've got several here. So these are all the treatments. We do the harvest stage, when should they be cut? We do harvest procedures, how, whether they should be handled dry to the shed or wet in buckets. Ethylene sensitivity, storage methods and duration, wet or dry storage, in a bucket or in a box, and then how long. Okay, grower treatments, in other words, hydrators in particular. Wholesaler treatments, these are hydrator and holding, various combinations. Sucrose pulses, especially flowers that have a lot of buds. Sucrose pulses will help those flowers open up more of the buds. Okay? Gladiolus is the poster child for that and responds very well. So you can get more buds to open up. It's very, very reactive to sugar, in other words, helps it. And then retailer and florist treatments. These are vase preservatives with or without foam. Now we know more flowers are being sold as bouquets, but we still do have a fairly large amount of flowers that are going into arrangements. And the question we get a lot of times is, how does it handle foam? Does it hold up in foam? Okay? Most flowers don't, well, I wouldn't say most. Maybe about half don't do as well in foam. And then there's a fairly large group that foam doesn't seem to have an effect one way or the other. And then there's a handful, very tiny amount, that actually do a little better in foam, which was a bit of a surprise. Okay, so Celosia, we're going to skip all the graphs for this part. So we're just going to get right to the information, the take-home message here. So early stage, they lasted longer. So when we had small heads, less than an inch. But the problem with that is the color. The bigger heads just had a lot more color. But keep in mind that, harvesting celosia younger, they will last longer, and that was about 10 to 14 days longer, so it was a pretty big deal. But again, you're going to have to harvest them for maximum consumer effect, and that's going to be larger. But keep that in mind. Store only in water. They didn't handle dry storage particularly well, and preferably for not more than a week. So this is one not to hold for too long. Flower Foods helped on this one, not surprisingly. Floralife Clear Professional, with or without foam. So this is one where the foam did not have much of an effect. So it handled the foam okay. They should not be put in a hydrator and or the holding solution together. Okay, so it did not like the two of them together, and it also didn't like being pulsed with sucrose. Okay? And that's the chief. I didn't say the cultivar there, that's the chief. I think it would be the same for most of the coxcomb types. All right, Aramuris. We talked a little bit about Aramuris. It's a big flower, so it's hard to take a good photo. These flowers are like this. They're pretty spectacular and all these. How many grow Aramuris? Just a handful? Okay, it's not the easiest to grow because it likes dry feet, especially in the winter. It likes well-drained soil. But if you are one that can grow it, it's a spectacular one. So the vase life, these stems were sent to us from Chile, actually. There's a grower and a researcher in Chile. Because we do not do particularly well with the Aramuris because of all of our rain. So the vase life was longest when they were harvested well colored, but the florets had not yet opened. Okay? We did two different cultivars, and we found a little bit of difference between the cultivars at times. Line Dancer did best when they were processed in water immediately, and Tap Dance did better dry. Okay. Stems did not like to be stored more than a week, but they could handle a week. STS actually helped overcome ethylene here on this one, so this would be another one where the anti-ethylene agents would help. And this is one, not surprising, because of all the buds. Okay, these big long stems, lots of buds. The sucrose pulse helped more flowers open up. Okay, so again, it fit the rule. Not all flowers fit the rule. Like Allison said, there's lots of exceptions, but things with lots of buds, generally more sucrose helps those buds open up. And then they did best continuously in floral preservatives, so making sure the customers get the packet is very important. They should not be placed in hydrator and holding together. And they did not like floral foam. So this is one where the vase life went down in the floral foam. Okay. Marigold, all right. Who likes marigolds here? I'll just start with that. All right. Who doesn't like marigolds here? See, that's how fast Alice's hand went up? So we have a constant discussion. Marigolds have gotten more popular in the last 10 years. And we've been doing a lot of them in the trials. And Allison's been really, really excited about that. All right, harvest. Harvest when more than 50% of the petals are open, again for visual quality. They can handle being stored dry. They're a little more durable than some of the others, but no more than 2 weeks. And they should be hydrated after harvest with either STS, Floralife Hydroflor 100, or Chrysal. So the commercial hydrating solutions worked on this one, as well as STS, and then pulsed with Hydroflor, followed by Clear Professional Flower Food. And we've seen this in the stage 1. The flower foods work on marigolds. It's been pretty clear. And then again, not surprisingly, they lasted the longest in the Floralife Clear, with or without foam. So this is one where foam, it handled the foam in the sense it didn't hurt it. So it lasted as long as without foam. Did not like sucrose pulsing, and their floral foam there, without flower food, it did not like foam. So I should have written that a little bit differently. So it handled the foam with the use of flower foods. If no flower foods, then it didn't handle the foam particularly well. Okay. All right, Snapdragon. Now these are the open face snaps, not the snappy snaps. Okay, so Again, like we saw with the first species there, harvesting early gave you the longest vase life, and that's when the lower florets had not yet opened. But later stage, they just look a lot better, okay, with 2 to 3 florets open. So this is one where you're going to have to balance, you know, like Allison said about the market. If it's going into a wholesale market and it's going to have time to develop, then you can cut younger, you'll get a longer vase life. If you're selling direct retail, you're going to need the color. You get a little shorter vase life, but obviously people will buy it, so that'll work. Stored dry, not more than 2 weeks. Hydrate, again STS like Rita talked about, or FloraLife 100 for 4 hours. 5% sucrose, worked on this one for 24 hours. So an overnight pulse of sucrose, not surprising, lots of buds on snapdragons, and so the sucrose helped those buds to open up. And it liked being in flower foods continuously, either the FloraLife or the Chrysal. It did not particularly like foam, so it did worse in foam. And one thing I'll mention, I'm going to divert just a little bit. We talked about carbohydrates earlier, and I should have mentioned it under the harvest time. What we really learned is that no matter how much carbohydrate we give them in the post-harvest processing, nothing replaces what's already in the flower when you harvest. Okay? So a flower that does not have a lot of carbohydrate in it at harvest will not last as long as one with a lot of carbohydrate, even if you give the first flowers lots of sugar in the vase solution. So you maximize what's in the flower, and then you maximize what you're providing the flower afterwards. So, yeah.
Okay, so thinking about the